So we did hyperbolas, trying to think if it was last, no, it was earlier this year, wasn't last semester. And they looked like this. We had hyperbolas that were there, like that. And then we have the negatives of those that looked like this. Oops, sorry, that goes down like that. All right. So we're not going to do those hyperbolas, done those. Those are of the form y equals 1 over x minus h plus k. And we're going to do ones of the conic section form today. And they look like, I'm going to center them at 0, 0 again, just to make these pretty understandable. They're going to look something like, oh boy, let's try that again. Let me place a vertex here. It's just too hard for me to do these without making the box. Oops. So we have some little graphing aids that we use for these. I'll show you about those. So I haven't put the hyperbola in yet. The hyperbolas look like that. And they're going to look like this. So they'll be horizontal and vertical hyperbolas. So they kind of look like those ones from earlier in the year, except they're oriented a little bit differently. Okay, so no problem. We can do these too. So the ones that are oriented horizontally, the first one, are going to be in the form x squared over a squared minus. Hyperbolas have a minus. The circles, the ellipses were all plus. The hyperbolas are all minus. Y squared over b squared equals 1. The ones that are going up and down are going to be y squared over a squared minus x squared. Whoops, I don't do this. We do this. Your book does this, but we keep the a's and b's with their x and y equals 1. These hyperbolas have a vertex and this distance from the center to the vertex, I don't know why that went away, is going to be A, and the ones that are oriented horizontally. Of course, we have a vertex for the other ones too. And the distance from the center to the vertex on these is B. Yes, ma'am. We always do A on the horizontal, B on the vertical. Your book doesn't. And it's okay to name them either way. We just kind of find it easier to keep the A's with the X's and the B's with the Y's. So on these, the A's are just going to be for the horizontal ones to find the vertex. The B's are going to be for the vertical ones. Oh, the B has a value. And remember with the foci, it's very much in the calculation of the foci. It's got to be in the and it's got to be part of the equation. And B is going to be this distance right here. That's the distance from the center to the top of a little rectangle, to one side of a rectangle. And it's not going to tell you where the vertex is, but it is a necessary part. And there's the A there. It is a necessary part to graphing these, figuring out what these hyperbolas look like. They have these little lines going through them, but that's not part of the graph. This purple line are the asymptotes. And let me make my little purple lines on the other one too. The asymptotes go through the center of the hyperbola. And the asymptote, the equation of the asymptote that goes through 0, 0 is going to be y equals b over a times x, and y equals negative b over a x. And that's going to be the same for either orientation. And if that center isn't at 0, 0, then that equation is going to have to be adjusted and translated over. But for right now, since we're doing the center at 0, 0, we're going to make things easy. The asymptote is going to be a very easy equation. B over a times x and negative b over a times x. A is the one that always goes with the x squared. B is the one that always goes with the y squared. That's the way we teach it in this course and in pre-calculus. Finding it easier to remember things, I think. Okay, so we're not going to do the focus today. Yay. Focus is, like, we've got enough to deal with right here. The focus is going to be there, just like it is with the parabola. So there's the focus. Okay, we'll get to that equation tomorrow. All right. So today we're going to graph some and find asymptotes. So let me get away from this very ugly, complicated picture and get down to a graph to do. So let me find one that I like. Okay, we'll do a hard one again. 4x squared. No, they're not really hard, but minus 16y squared equals 64. All right, this isn't in standard form. To go to standard form, we're going to divide